Hi everyone, today's lesson is about operations with radicals. So first we have to think about what a radical is. And no, I don't mean Jesus, I mean a number that has the square root above it. So something like this would be a radical. Root 5 is a radical. C root A represents a radical. Okay, so we can use rules to help simplify radicals that look like these. So radicals are preferable for a final answer if an exact number is required. So remember when you're solving an equation, often when I'm telling you I want the answer as an exact number, you need to write it as a fraction, not a decimal. Well, when you're doing Pythagorean theorem, when you're doing quadratic formula, you end up with a square root, okay? And you're used to just putting that in your calculator and popping out a decimal answer. But it's time now that you're able to learn how to deal with square roots so that you can leave your answer in square root form, which is really called radical form. So there's a few rules that we're going to go over today, 4 rules, and then do a couple examples. So the first rule is that root A times root B is just equal to root of A times B. Okay? Now remember that equalities go both ways. So that means that if you have root A times root B, that you can separate that into 2 roots, root A times root B. Okay, so this can go either way, depending on what you need for your purpose. So if you have root 5 times root 7, you can rewrite that as root 5 times 7, okay, which is equal to root 35, okay? If you have root 8 times root 2, you can rewrite that as root of 8 times 2, so root of 16, and aha, the root of 16 is just 4. So there you go, that's the first rule. Now think about if you have something like this, root 32, you can rewrite that as root 16 times 2. Okay, and we'll show a little bit later why writing it this way would be preferable to writing it this way. Okay, our next rule is that C times root A times D times root B is the same as CD root AB. So in other words, if there's coefficients outside of the radicals, you can multiply the coefficients to be outside and then multiply what's underneath the square root to be inside. So if you have 2 root 3 times 4 root 5, you can do 2 times 4 is 8. And then square root of 3 times 5, which is 15. Okay? It just looks nicer. The negative 5 root 2 times 3 root 7 could be simplified to minus 15 root, not 21, 14. Okay? So those are the first 2 rules. Okay, rule 3. So this is addition. So note, this is very similar to what we just did, but that was multiplication, and this one is addition. So C root A plus D root A. So also notice that these are square rooting the same number. Okay? So really what you're doing here is just collecting like terms. Okay? So if you have C root A's and D root A's, altogether you have C plus D root A's. So if you have 2 root 5's plus a root 5, this is just 3 root 5, okay? Again, you can think about it like collecting like terms. 5 root 7 minus 2 root 7 will give you 3 root 7. Okay, and finally, now this will come into play, that whole 16 times 2 instead of root 32. If you have something that's squared, so a squared times b, then you can take this perfect square out and put it on the outside. Okay, so we'll show you what that means. So root 18 can be written as many things, okay? Well, not many things, but there's a few things. It could be rewritten as root of 3 times 6. Okay, don't write this, just watch. I could rewrite this as root 3 times 6, but that's not anything particularly exciting. That doesn't change what I'm doing here. But I could also rewrite root 18 as root 9 times 2. Now, why is that better? Well, because 9 is a perfect square, right? 9 is just 3 squared. So because this is just 3 squared, I can take the square root of this and put it on the outside. So I can just make this 3 root 2, okay? This is what you'll be doing often with the quadratic formula. So you look at the number that's under the square root and you say, can I write it as a product of a perfect square and another number? And of course, you'd always like the perfect square to be as high as possible, okay? So that's what you're trying to do. And then if 2, again, was a perfect square, which it isn't, I could rewrite it again and pull out its square root and keep doing that until I have it in simplest form. Okay? So again, 12 can be rewritten as 6 times 2 or 12 times 1, but we want to write it as 4 times 3 because 4 is a perfect square. And just for my own benefit, I like to put the perfect square first. Now, either you can go right to the 2 root 3 if you like, or you can rewrite this, that's 2 squared times 3 to show you that it's the 2 that you're taking out because it's the root of 4. So that gives you 2 root 3. All right? And then 120, okay, you need to think here. Can you rewrite this with any perfect squares? Okay, so can it be rewritten with 4 or 9 or 16 or 25, 36, etc. So think of all the perfect squares. And if you need to, take out a calculator and see what it's divisible by. So in this case, it can be rewritten as 4 times 30. Okay, so you take out the root 4, so you have 2 root 30. Now to make sure this is as reduced as possible, you think, are there any perfect squares that go into 30? 4, no. 9, no. 16, no. 25, no. So there aren't. So this is your lowest form. So those are the 4 rules. Make sure you familiarize yourself with them. And then we'll do the 2 examples. Okay, so it says simplify and it's 2 binomials. So really you just FOIL this as you would any other problem. You just have to consider the rules of radicals. So you do 3 times 2, which is 6, and then plus 3 times root 24, minus 2 times root 6, minus root 6 times 24, right? Because if it's root 6 times root 24, you can multiply that together. Okay? So this gives you 6 plus, now we want to simplify this. Okay, so we have 3 on the outside, and we can rewrite 24 with a perfect square. Okay, so we can rewrite it as 4 times 6. Okay, and root 6 cannot be simplified any further. And this is root 144 because 6 times 24 is 144. Okay, so now we still keep the 6. We take out this 4. This just becomes, this is 2 squared, right? So we're taking out the 2 and putting it outside, but it has to be multiplied by this 3. So this becomes 6 root 6. Okay? Now again, it's because it's root 4 times 6. The square root of 4 is 2, so I'm taking that 2 out, but it has to be multiplied by the coefficient that's already there, so that becomes 6, okay? And then this is just 2 root 6, and oh, root of 144, that's just 12. That's a perfect square. Okay, so we're not quite done yet because we can collect these 2 like terms, and you can collect these 2 like terms. So you have minus 6 plus 4 times root 6. And that's your final answer. Okay? Now you could common factor a 2 out of here if you wanted. And you'd be left with minus 3 plus 2 root 6. And there you have it. Okay? That's the first example. So take a look at that. Make sure you get all of the steps. And make sure you understand why you need to do as much as you do to get it down to the fully simplified form. Okay, find the zeros and express the answer in reduced radical / rational form. So this really is the whole point of why we're learning this section, is so that you're able to do things like this. So when you get to quadratics and you're finding the zeros, or you're using quadratic formula, that you can write something as an exact number and not just as a decimal, which is actually an estimate. It's not exact. Okay? So we use quadratic formula to find the zeros because it's not factor rule. So x equals -4 plus or minus the square root of 4 squared minus 4 times 2 times 1 all over 2 times 2. Okay? So this reduces to -4 plus or minus root 8 divided by 4. Now a big mistake that people make here is that they cross these 4's off. Okay, why can't you do that? Think about it. Because there's addition and subtraction here. Okay, you can only reduce this if it's a common factor. So what I want to do first is simplify this radical. So it's -4 plus or minus. Now root 8 can be rewritten as a product with a perfect square. It can be rewritten as 4 times 2. Okay, and I like that there's a 4 there because I know that's a perfect square. Now, can you cross the 4's off? No, because this isn't technically a 4, it's a root 4. Okay, I'm going to keep going this way just to make sure it all fits on the screen. So then I have -4 plus or minus 2 root 2 all over 4. Okay, so I took the root of 4, which is 2, and put it on the outside, and the root 2 was still left under there. Okay, so now I can pull out a 2. I have -2 plus or minus root 2 all over 4. And I can reduce these to 1 over 2. Okay? So I'm left with -2 plus or minus root 2 all over 2. Let me extend that like that. Okay, so this is your final answer. You can't cross out the 2's because this is a root 2, not an actual 2. And you can't cross off these 2 because there's still addition and subtraction on the numerator and not the denominator, so you can't reduce that any further. So this is an example of an answer that is written as an exact number. So those are your 2 zeros. X equals -2 plus root 2 over 2, or -2 minus root 2 over 2. So when you get to the problem solving section of the homework, it'll ask you to write your answer as an exact number. So this is how you do it. Okay, so make sure that you really understand how I did this here. The key is, the first step really obviously is writing the quadratic formula down, but then simplifying what's under the square root to just one number. That's really crucial, a crucial part of this. Okay, so this is something that your calculator may not be able to help you with anymore in terms of how it's supposed to look at the end. So thank you so much for watching today, and I hope you learned lots.